Suppose that we're trying to test the hypothesis that the average income is, let's say, $95,000 for people in the Bay Area. All right, so we say average income equals $95,000. Okay, now, so we go out and let's say we collect the sample. Let's say we can sample here n equals 200. Okay, so we ask 200 people what their income is, and then we take we take the average, and we find out that the average is let's say $45,000. Okay, now the question is, okay, is there evidence for me to suspect that this might be false? The null hypothesis is false. Now, first of all, is it possible? Yes, of course, right? Given that the average income is $95,000, it is still possible that in a sample of 200 people, I get an average of 45,000. Right? It is possible, although it is unlikely. Right? And then now, so you say, well, this is still, it's not so unlikely that I will reject this. Now, how about what if I get a sample average, right? That go out tomorrow, I get a sample average, and it turns out that it is $15,000. Okay. Again, is it possible? Yes, right. You just might happen. You just randomly met 200 people with very low income in the Bay Area. However, right now, if this is too unlikely, right, that you see 15,000, then you might say, well, I will question, I will question this. Now, so this is why in previous chapter 7 and chapter 8, we talk so much about sampling distribution, because this is so. Given that the null hypothesis is true, so if the null hypothesis is true, which means the sample mean will be centered at 95,000, right? Which is at the mu, right? That's the hypothesis. That's the hypothesis here. And so 45,000 will be 45,000 or 45,000 will be about here. Now the question is this? What the question will is how far is this? Now I don't mean by how far in dollar terms. What I mean by how far is it in terms of standard deviation. Right? How many standard deviation away is 45,000 or maybe even 15,000? Right? How far is it away? This will give us an idea how likely is it I am to observe these observations given that the truth is 95,000. If it's too unlikely, given the null hypothesis, then we will reject the null hypothesis. And that is essentially the basis of hypothesis testing. So what we're going to do is convert these observations into test statistic. So the formula for test statistics is very simple and looks very familiar. It is simply x bar minus mu naught, so this is the mu of the null hypothesis, divided by the standard error of x bar. Okay. And what we've done, once you do that, then you would have converted the observations into this test statistic. So your test statistic is going to center at 0, and this will be this will be negative on the left and positive on the right. Right? And this will be approximately normal distribution, and we can compare. Now we can use the z distribution. We can use the z distribution or the t distribution, right, to figure out how the likelihood of these observations. So let's do an example. I think will become a little bit more clear. So example 1. Okay. To test the hypothesis that the mean age of university professors equal to 55, a random sample of 1,000 faculties is collected. The sample produce a sample mean of 53.5 with a standard deviation of 5.3. All right. So when you start reading these questions, get in the habit of collecting the information. We want to test the hypothesis. The mean age is 55. So the null hypothesis is going to be the mu equals 55. Okay, then the alternative is going to be that is not equal to 55. Okay, random sample of 1,000, n equals 1,000. Okay, and then we get a mean x bar equals 53.5. Okay, furthermore, our sample standard deviation is 5.3. Okay, calculate the test statistic. Now, first thing we need is the sample error. Oh, sorry, the standard error. So the standard error of x bar is 5.3 divided by the square root of n, which is 1,000. We get 0.1676. Okay. All right. Now, visually, this is what's happening. So we have x bar. It is normally distributed. Now, how can we say it's normally distributed? Well, because we have a sample size of 1,000. So remember, central limit theorem says that if it's greater than 30, we have a normal distribution. Furthermore, this is centered at 55. We always assume that the null hypothesis is true to begin with. Okay, and then we observe 53.5. And now what we want to know is how far is it from 55 to 53.5? Is this an extreme value? Right? And we need to calculate that in terms of the test statistic. So here we go, test statistic. 53.5 minus 55 over the standard error. Okay, there we go. Now, so what that means is if I convert this to a standardized, a standardized distribution, this is 0 and all the way, so -8, right, we know that will be all the way down here. So that is pretty extreme. It is very, very unlikely. Okay, so then we will likely now here. So if we get this observation, right, now we can see that, well, if the null is true, this is an extremely unlikely observation. Therefore, right, I want to consider rejecting this hypothesis. This mu equals this average age equals 55. Now, how far is too far? What do we mean by extreme? We'll talk about that next. Okay, but right now, just focus on calculating the test statistic. Let's give this one more try here. Right? So I have a. So go ahead and read this, and then go ahead and calculate the test statistic. Pause the video if you like, and you can check your answer here when you're done. Okay, I have a sample size of 200, which is greater than 30. Therefore, I can go ahead and know that, or imply that my sample mean is distributed normally. I center at the mu naught. Okay, and my standard error of x bar equals 300 over square root of 200, which equals 21.21. Here you go. Now I have everything I need to calculate my test statistic. Right? So here's my sample mean. X bar is 4117. Oops, there's 0 there. 4117. Right? Minus 4100 all over 21.21, and this gives me 0.802. Okay, and so we are very close. Right? Actually, so once we divide it by the standard error, we can see how far is it actually from the mean, right? And we can say, right, or what this is so the test statistic measures how far, and let's put far in the quotes here, how far the observation is okay, from the mean, or from mu. And that's the mu we're talking about is the mu of the null hypothesis.